Thank you for that, Sir Brett. Again, good day everyone. I am Anne-Michelle Diaz, and our discussion for today focuses on understanding and managing two critical processes that transform the Earth's surface, namely soil erosion and mass wasting. These processes influence the health of our ecosystems, the safety of human communities, and the sustainability of agricultural practices. By the end of my presentation, we'll better understand how we can minimize their adverse impacts while embracing sustainable land use practices. As Wendell Berry once said, the earth is what we all have in common. So this reminds us of our shared responsibility to protect and sustain the earth for future generations. Now, let's start by diving into soil erosion, or often referred to as the silent thief. So here's an overview of what we'll explore. Now let us begin with soil erosion, or the unnoticed process that steals the Earth's surface resources bit by bit. So soil erosion refers to the detachment, transport, and deposition of soil particles. So this process is driven by natural forces such as wind, water, and gravity, but it is often intensified by human actions. So the key stages are in which the first one is detachment, in which soil particles are loosened by natural or human disturbances. Second is the transport, in which these particles are carried away often by rainwater, rivers, or strong winds. The third one, deposition, in which the soil is eventually deposited in new locations, often causing problems like sedimentation and waterways. While erosion is a natural process crucial to landscape evolution, when accelerated by human activity, it becomes a major environmental issue. Next, we will explore what triggers soil erosion, both naturally and through human intervention. So there are two primary categories of causes of soil erosion. So first, the natural causes. So for the first cause is that the rainfall intensity, in which heavy rainfall loosens soil particles, especially in areas with inadequate vegetation cover. Second is wind strength. So in arid and semi-arid regions, strong winds erode topsoil. And the third one for natural causes is that the topography, in which steep slopes are more prone to runoff and soil loss. The second category is human-induced causes. So first, the deforestation. Tree roots bind soil. Removing them destabilizes the surface. Second one is overgrazing. So livestock exposes soil by consuming vegetation. Third one is poor agricultural practices. So monoculture and plowing leaves soil exposed to erosion. And the fourth one, which is the last one, is the urbanization. So these paved surfaces increase water runoff, accelerating erosion. So these factors demonstrate how our actions can worsen natural vulnerabilities. So now I have a question. So how do our everyday activities accelerate erosion? So let us explore this question in the context of the Philippines, where the impacts of soil erosion are vividly felt due to the unique interplay of natural and human factors. So in the Philippines, where heavy rains and mountainous terrain are common, soil erosion is a recurring challenge. So in South Cotabato, severe erosion has damaged schools and agricultural land. Alpay experts significant erosion on its volcanic slopes, especially during typhoons. In Baguio City, roadside erosion disrupts transportation and threatens nearby communities. So these examples underscore how soil erosion can undermine livelihoods and infrastructure. But this isn't just a local problem, it is also a global issue. So around the world, soil erosion poses similar challenges. So in the European Mediterranean region, agricultural activities and drought exacerbate soil loss. And next example is in the United States, nearly 1.7 billion tons of soil are lost annually, reducing farmland productivity and increasing water pollution. So these global examples highlight the urgent need for collective action against soil erosion. Let's now look at the consequences of this silent thief. So now let us all explore the impacts of soil erosion. So the effects of soil erosion are far-reaching. So for the environmental impacts, loss of fertile topsoil decreases agricultural productivity. Sedimentation clogs waterways, disrupting aquatic habitats. Desertification worsens in arid regions, making land unusable. For human impacts, farmers face higher costs to restore degraded land. Food security is threatened due to declining crop yields, and infrastructure like roads and dams suffers damage from sediment accumulation. So these consequences emphasize the need for effective management. So speaking of management, let us explore some solutions so that we can answer the question, how to prevent soil erosion. So in managing soil erosion, we have the effective management strategies combine natural, engineering, and policy solutions. For natural approaches, planting vegetation stabilizes soil and reduces runoff. So cover crops protects soil from erosion during the off-season. For the engineering solutions, contour farming and terracing slow water flow on slopes. Retention basins collect runoff, preventing sedimentation downstream. For the third one, policy actions, educating communities about soil conservation is also one of it. Implementing sustainable land use regulations. So these methods show that erosion can be controlled through targeted efforts. So now that we've explored various strategies for managing soil erosion, from natural methods like planting vegetation to engineering solutions like terracing, I'd like to leave you with a question. Can you think of any ways to protect your area from soil erosion? It's important to consider how these solutions can be applied to your local context, whether it's promoting reforestation, practicing sustainable farming, or advocating for better urban planning. Each of us has a role to play. So with that thought in mind, let us shift our focus to another significant process that reshapes our environment, or what we call the mass wasting. So the power of gravity in motion. So mass wasting involves the downslope movement of soil, rocks, and debris due to gravity. There are three main types of it. So first is falls. So rock fragments break away and fall freely, often due to weathering. Second is the slides. Material moves along a defined surface like landslides. Third one and the last one are the mixtures of soil and water that behave like fluids as seen in mud flows. So mass wasting is driven by gravity but often triggered by external factors like rainfall or earthquakes. Now let us examine these triggers more closely. So this is the slope stability and the processes that shape our landscape. So as you can see in the picture, for the soil creep, it is the slow movement of soil downslope seen in tilted trees or damaged roads. For solifluction, occurs when water-saturated soil flows over a hard or frozen layer, common in areas with permafrost. For the third, in which it is slumping, in which it happens when soil slides along a curved surface, leaving a headscarp and displaced material. So, for the lahar or mud flow, this involves volcanic material mixed with water moving quickly and causing destruction. For the debris flow, it is similar but includes soil, rock, and organic matter, often triggered by heavy rain in the forested areas. So rock slide involves rocks sliding down slopes due to erosion or weakened layers. For the rock fall, it is the free fall of rocks from steep cliffs. For the rock avalanche, it is a large-scale rapid rock movement on steep slopes. So these processes are driven by gravity, water, and even human activities like deforestation. Now let us find out what are the factors that would greatly influence mass wasting. So mass wasting is influenced by natural factors in which earthquakes and volcanic eruptions destabilize slopes. Another is that heavy rainfall or snow melt saturates soil, reducing its strength. And for the third one, or weathering weakens rock formations. For human factors, construction activities disturb slopes. Second one is deforestation removes natural barriers that stabilize soil. And for the third one, mining and quarrying disrupt geological structures. So these triggers highlight the delicate balance between slope stability and external force. So next we'll explore the consequence of mass wasting. So the effects of mass wasting include the environmental consequences and human consequences. For the first category is that destruction of habitats and ecosystems, alteration of river courses impacting water availability. And for the human consequences on the other side, damage to property and infrastructure, loss of lives in extreme events, especially in landslide-prone areas. So these impacts demonstrate the importance of preparedness. So now let us explore real-world examples of mass wasting. So here are the cases of mass wasting around the world. So now we will believe that this occurs worldwide. So often with devastating results. No? So in the southern Philippines, for example, frequent heavy rains and deforestation lead to deadly landslides. For the international case in Ontario, Canada, slope failures occur due to natural weathering and human activities, threatening nearby infrastructure. And lastly, for El Salvador, volcanic soils and intense rainfall cause downslope movements of rock and debris, severely impacting communities. So these cases emphasize the widespread and diverse impacts of mass wasting, from loss of life to habitat destruction. So now, can we predict and mitigate the impacts of mass wasting? This is a critical question because understanding and managing these events can save lives, protect ecosystems, and reduce economic losses. So for managing mass wasting, so this involves a combination of natural approaches, engineering solutions, and preparedness measures. For the first one, reforestation stabilizes slope by strengthening soil through root systems and reducing water infiltration. Avoiding construction in landslide-prone areas ensures that human activity doesn't exacerbate instability. Second is for the engineering solutions, in which retaining walls and slope reinforcements add physical support to unstable areas. Drainage systems reduce water saturation in the soil, one of the leading triggers of slope failure. For the third one, early warning systems such as monitoring slope movement or weather conditions provide critical time to evacuate or take precautions. And also educating communities is also very important about safe land use practices helps reduce risks in vulnerable areas. By combining these strategies, we can reduce the impacts of mass wasting, although it requires collaboration between governments, communities, and individuals. Now, I'll leave you with this thought-provoking question. So what is more effective, prevention or preparedness? I think both are vital, but which do you think has the greater impact in reducing the risks associated with mass wasting? Okay, so now that we've explored both soil erosion and mass wasting, let's reflect on what these processes mean for the future. So both soil erosion and mass wasting are natural processes, but human actions often intensify their effects. Sustainable land management and environmental stewardship are key to reducing their impact. For soil erosion, this means protecting fertile lands and ensuring food security. For mass wasting, it means saving lives and preserving infrastructure. Ultimately, awareness and collaboration are vital. Communities, governments, and individuals must work together to mitigate these processes. The earth will outlive us, but it's our responsibility to ensure it thrives while we're here. So let's conclude with a call to action for all of us. As we've seen, soil erosion and mass wasting are powerful reminders of how interconnected we are with Earth. These processes, while natural, are amplified by our actions, reminding us of the delicate balance we must maintain. By adopting sustainable practices, educating ourselves and others, and embracing collaboration, we can protect the environment, safeguard our communities, and leave a thriving planet for future generations. So thank you for joining me, us or rather, in exploring these critical topics. So let us commit to reshaping our actions today to ensure a better world tomorrow. Once again, I am Anne Michelle Diaz, and thank you for listening.